Hello, welcome back to this channel. Today we're going to introduce the three-phase system. Before we do the three-phase power flow and three-phase circuit analysis, today we're going to have three short videos, and we're going to discuss the balanced three-phase circuits, just to introduce what these balanced three-phase circuits are, and then we introduce the phase voltage, or the line to neutral voltage, and the line voltage, or the line to line voltage. And then the last topic would be on the positive sequence and negative sequence. And these are all basically the concepts that's specific to the three-phase systems. Let's get started with the three-phase balance system. And for the three-phase system, we are interested in the balance system because in the practical systems, let's see the power system, most of the majority of the power is transmitted through the three-phase systems. Like the transmission, you see this on the towers, you get three-phase lines. Sometimes you see 6 lines because that's 2 sets of three-phase circuits. And then the distribution system also three-phase until to your house, and that becomes a single phase. And also for the equipment, let's see either electric machines that are used in the electric vehicles, right? Right now the electric vehicle is very popular, and those electric machines inside the electric vehicle, they are almost always three-phase. And like power converters, you also have three-phase power converters, like the PVs, the solar inverters. And for the larger ones, more than 10 kilowatts, typically that would be three-phase. For the residential system, that typically single phase, because at home you don't really have three-phase loads. But let's look at what the three-phase balance circuits are. For the sources, if the voltage, if the magnitudes are the same, and the phase angles are displaced by 120 degrees, and then they form a balanced three-phase source. And for the load, if the impedance, if each phase impedance is the same as the other phases, and they form a balanced three-phase load. So if both the source and the load they're balanced, we call the three-phase circuit are balanced, right? So let's look at a very specific circuit, and it's very interesting to see some of the benefit of a three-phase system. Let's look at this. So I have the three-phase sources. Now each of the magnitudes, now they are given in phasors, and each of the magnitude is 120 volt RMS, and the phase angle, look at the phase angle there. So the phase angle for VAN, this voltage, this is 120. Basically, this phase angle 0. Right? So there is no the angle that's 0. And for VBN, that's negative 120 degrees, right? The same magnitude. For VCN, it's positive 120 degrees. So if you draw the phasor diagram, which is very useful for the three-phase system. If we draw the, so this is going to be VAN. We draw the phasor diagram. We assume this is going to be the real axis. This is going to be imaginary axis. We typically don't draw these. Okay, we assume the horizontal is real and vertical is imaginary. And so this VAN has 0 phase angle, and the VBN has negative 120 degrees, roughly this. So this will be 120 degrees. So this is VBN. And you got a VCN here. And this is another 120 degrees. So they, of course, this is going to be 120 degrees as well, because there's 360 total, right? So they form a balanced voltage source, and then I have the load, the same impedance Z sub L for each phase. So therefore, we have a three-phase balanced circuits. And let's see, try to find the neutral. Let's see, find the neutral current. Let's see, given here, we're trying to find I sub n. And let's see, first we find I sub A, I sub B, and I sub C. Okay, so I sub A is going to be equal to VAN. This is very simple, right? Each circuit, you have the voltage, you have a single impedance divided by Z sub L, and you have I sub B is going to be equal VBN divided by Z sub L, and I sub C is equal V sub Cn divided by Z sub L. And if you apply the KCL at this point or at this point, you will get I sub n is going to be equal negative IA plus IB plus IC, right? And the quickest way to get this the current using KCL is you use the leaving current equal to sum of the entering currents, right? Or the vice versa. So at this point here, so the leaving current is I sub n, so entering current is negative as each of these, the sum of these, right? So therefore, and we get so we can factor out this Z sub L, right? We get a VAN plus VBN plus VCN times negative 1 over Z sub L. And if you add these three, you can do the use a calculator, right? Or you can use the phasor diagram. And if you add this one, and you get negative, right? So this 6 degrees, 6 degrees. This should be 60 degrees. Although my drawing is not perfect, but I know this one would be equal, the VCN plus VBN would be equal negative 120, and plus VAN, that's 120. So this is going to be equal to 0. So for three-phase balance system, this I sub n, we call this neutral. This is neutral line. The neutral line current is 0. Right? This is very appealing. The reason for that is since this line is 0 current, now why I need this line, right? I can just simply take that out, just like this. If I take that neutral line out, the current IA, IB, IC here would be identical to the current IA, IB, IC in this circuit, right? This is three-phase 4-line system and the three-phase 3-wire system. They're the same, right? So this is a very useful feature for the three-phase system, because think about it here, I only use 3 wires, right? 1, 2, 3 to transform 3 times the power, right? So it has huge advantage, especially if you transfer the load is very far away from the source. You transfer power over a long distance, and this will save a lot of the cost compared to you use 3 single-phase circuits, right? So 3 single-phase circuit would require 6 wires, 1 go, 1 return for each phase. So times 3, 2 times 3, you got 6 wires. So now you got only 3 wires. So this is one of the biggest advantage of the three-phase system. Okay, as we do the circuit analysis for three-phase system, we're going to understand more how we calculate the power, so on and so forth. Right now, we just need to know the concept of what the three-phase balance system, and for three-phase balance system, the neutral current is going to be 0. Okay, that's the very cool feature for a three-phase system, and that's the reason you don't have the single phase, and also there are other advantages as well. Okay, so next we're going to look at the next topic in a moment.